Everyone. So what we have today, this video is going to be a little bit of math, just to familiarize yourself with what we're trying to do. And in future videos this week are going to be about work and kinetic energy and conservation of energy. So what we have here, I want to talk about, we talked about vectors. We talked about adding them and multiplying one by a scalar, but we didn't talk about multiplying two vectors together. And I want to give you a definition, what's called the dot product. And what that does is it takes two vectors and multiplies them and gives you a number out of it. And so we express it as vector A dot vector B. Right? And so if we do that, well, the definitions I've given you, there's two versions of the definitions. One is the length of A times the length of B, those are vectors, times cosine of the angle between them, which I'll say is theta AB for the moment. I just called it theta in the notes, and that's okay. But I don't want you to get confused is when I specify what angles are, sometimes I'm specifying the angles relative to the x-axis. And I'm specifying how A is written. Like, let's say A is 20 meters, and it is 60 degrees above the x-axis. So that's a vector that looks something like, I'll draw it out here. This represents our vector A, let's say, and this is our 60 degrees. So this angle has nothing to do with the x-axis. It is between A and B. So I need to specify, an angle for B, let's say. So let's say B is 3.5 newtons, and it is at 95 degrees above the x-axis. So if I want to draw that, that's going to be like that, let's say. And I'm not putting numbers on this because obviously I have meters on one vector and newtons on the other. And what I happen to see here, I've drawn this out. I can kind of outline what's going on is if this angle is 60, this y-axis is 30, and if this whole angle is 95, this one is 5. And so theta AB should be 95 minus 60 here. The way I've drawn it is going to be 35 degrees. So you have to be careful. You have to specify that it's this big angle that we care about when we're trying to multiply these vectors out. So the other bit I want to say is that there's a second definition, and that has to do with the components. And so we'll eventually go through and get the components of A and B, and then I'll show you what these products look like. So the definition in terms of the components is A sub x, B sub x, plus A sub y, B sub y, plus, if it exists, A sub z, B sub z. And if you're doing math instead of physics, then this can go to however many components your vector has. So we have two different definitions. They should be equal. Here, what we have is A dot B is going to be 3.5 newtons times 20 meters. That is this bit. And then we're going to have cosine of 35 degrees. And now, this will have some units. We'll leave it as Newton meters for now. To demonstrate what we're doing, we're just going to do 3.5 times 20. That should be 70. And then we'll multiply by cosine of 35. And that is 57.3 Newton meters. That is your units. It's just multiplying the units together. So this thing is defined. This thing is the thing you'll learn in future videos. That's a joule. Is 1 Newton times meter. So we also need to go and consider the components. What components are relevant in this problem? And does it give you the same thing? If we do this procedure, do we get the same thing? So we're going to find a sub x is 20 meters cosine 60 degrees, and that is, give me a moment here. I'm going to do something slightly different. Well, cosine 60 should be 1/2, so this is going to be 10 meters. A sub y is going to be 20 meters sine 60 degrees. That's going to be square root of 3 over 2. And that gives us 17.32 meters. And then we do the same thing for B. Right? Bx is 3.5 newtons cosine 95 degrees. The way we've drawn it, we expect it to be slightly negative, so we should check that. So 3.5, what I get is minus 0.31 newtons. B sub y is 3.5 newtons. Sine 95 degrees, and that is 3.486 newtons, or 487 newtons. And it rounds 3.49. It's almost 3.5. By the way, what I was doing here, let me see if I can zoom in a bit. So on your calculator, so you'll notice on the calculator, you may have these functions, and they're for converting from rectangular to polar. And that is exactly doing the sines and cosines, and vice versa. So what I did was, say 20, and then I'm going to convert to rectangular, and then I put in my angle, it's 60. And that gives me, the x part, and then my calculator will give me the y part. So on your calculators, on the TI-83s that everyone uses, there is a function that does that, and it doesn't hurt to know how to use it. But it doesn't hurt to also know that this is what you're doing. So, that's an aside, Anyway, what we want to find is AX plus BX, sorry, AX times BX. That's 10 meters times minus 0.31 newtons. That is 3.1 minus Newton meters. And then AY, BY is going to be 17.32 meters times 3.487 newtons. I don't know what that is off the top of my head, so 17.32 times 3.487 is 60.39 Newton meters. And so we subtract these, or we do AX BX plus AY BY, and that is 60 minus 3.1, 57.3 newtons meters. And that is the same answer we got there. So at least with random numbers that I pulled out of my head, this holds. And you can, that is a job for the vector calculus class. Prove but these definitions should be the same. It's a bit of geometry to prove that this is really some function of these sines and cosines that makes this make sense. Anyway, that's the dot product. I wanted to show you working with that. And there's some other ways you can work with it. But what's relevant to us is doing this sort of calculation to find the work that a force does in moving an object. So we'll pause the video there, or stop the video, and you'll get the next one on the actual physics that we're talking about.